Okey.
Okey,
Assalamualaikum.
Assalamualaikum.
Waalaikumsalam.
Alright,
Apa
apa
pasal
khabar
ni?
semua?
Okey, apa khabar semua? Okey, selamat malam.
Waalaikumsalam.
Semua dah makan
Tu
tu
kita
belum?
dah ada dah. Rakan-rakan kita dah ada masuk dah ni.
Betul. Ramai dah tunggu daripada
Yes.
pukul berapa saya jumpa tadi kalau ikutkan. Saya jumpa tadi daripada seawal jam 6 petang. Kita
Wow.
punya. Ya, 6
Itu
petang
dia.
dah menantikan sesi kita pada malam ini. Terima kasih
Yes.
pada yang menanti, yang setia, yang sedia meluangkan masa walaupun malam ni bukan malam minggu. Malam ni malam Rabu kan? Selasa malam
Yes,
Rabu.
malam Rabu. Selasa malam Rabu. Yes. Dan anda
Yes,
bersama
yes.
kita pada sesi malam ini, Meet and IAU Meet and IAU.
Apa yang Azim?
Berbelit. Sorry. Sebab kita ada
Astronomer.
tetamu daripada luar kan. So it's quite
Yes.
exciting to be to have a panel from outside, from
Wow.
overseas. Yeah.
He's trying to speak in English right now. So
kena
you can
berlatih
see
dulu.
that? Yes.
Okay, so anda bersama kita dalam sesi Meet the IAU Astronomer, Where Are
Yes.
the Martians bersama Dr Kundan Kadam. Dan
Where
kita akan
are
live
the Martian? Where are the Martian?
sahaja lagi. Betul. Dan kita dah terima pun soalan-soalan anda, soalan adik-adik, soalan tuan-tuan perempuan yang dah tanyakan soalan kepada doktor lebih awal. InsyaAllah mana soalan-soalan yang terpilih akan ditanya kepada doktor pada sesi Q&A pada malam ini.
Tapi pada masa yang sama, kalau anda semua ada soalan, mungkin terfikir kan, boleh tanya dekat ruang komen. Nanti kita akan pilih soalan-soalan yang menarik untuk dibawa bersama dijawab oleh doktor. Okay. So kita tak lama sebenarnya. Sekejap lagi kita nak cakap single saja.
Betul. Kita warm up dulu ni. Okay. Jangan lupa sampai di Facebook, di YouTube, sharekan kita punya sesi pada malam ni kepada rakan-rakan anda, kepada keluarga anda dan kepada guru-guru dan juga grup sekolah korang. Bagi semua join malam ni.
Tajuk malam ni memang best sangat sebab dia cakap pasal Martian. Kita cakap pasal alien. Kita akan cakap pasal life in other planet. Okay, alright. So kita boleh mula? Kita boleh mula. Jom.
Ada satu satelit, dia mencerap matahari, ada banyak solar filter. So dia boleh tengok matahari tu warna yang berbeza-beza.
exoplanet together with its hosting star.
제가 영상을 하나 보여드릴게요. Next.
Deepest appreciation to
アジアの皆さんに少し天の岩戸のお話を紹介しております。
Ta-da!
Okay.
All right, okay. So, all right, we have watched all the quite long movie actually, introduction.
Yes, a
So
brief
tonight,
introduction about all of our program and also our tonight's program.
yeah, it's a special program actually. We are bringing our best speaker and guest from out of Malaysia.
Yes.
We will introduce him soon. Okay. So now, okay, without further ado, I think we should introduce him a little bit. Before
Yes.
we just introduce him a little bit only, then doctor, I think he'll introduce himself better lah. Right. Okay. So who's our guest tonight actually, Adam?
Yes, okay. So our guest tonight is Dr. Kundan Kadam. Okay.
Yes.
He is an astronomer, an IAU astronomer. IAU stands for International Astronomical Union.
Yes.
And he's going to be with us to talk about a topic, where are the Martians? Okay, so
Yeah.
it's an interesting topic where we will discuss more about, is there life on Mars? Okay, so if you have
Yeah.
any questions to ask, just leave it in the comment section, and if we have enough time, we will collect your questions and we will ask to our panel tonight.
Yeah. For those who doesn't know what is actually IAU, IAU stands for International Astronomical Union, the body who governs all its astronomy events and activities around the world. So it consists of numbers of astronomers, professional astronomers working on
Yeah.
it. So Dr.
Even we
Kundan
have
Kadam is
IAU
part.
astronomer registered in Malaysia too.
Yeah, we have numbers. Yeah,
Yeah.
cool. So this topic will be around astrobiology topic. Some of our audience ask us to speak in Malay, but I think we will, if permitted and allowed, we will use a little bit Malay. If you want to understand, you need to translate it later. All right? Okay. Don't worry. We try to have
Yes.
you guys to understand what are going to talking about. Okay.
Okay.
So I think some of them are really waiting for our guest. We are bringing him far away from Canada.
Canada.
All right.
Okay. Welcome, Dr. Kundan
Doctor.
Kadam. How are you?
Hello, everybody. Yeah, I'm good. Thanks for this
Cool.
opportunity.
So welcome to Malaysia online.
Yes, I'm very excited for this event.
Yeah, here currently we are around 9 p.m. And so
Yes.
what is your
Yeah.
time?
Yeah, it's about 8 a.m. here. And I'm in Canada now. It's very cold, so very different weather.
But you wear just a simple, sleek shirt.
Yeah, we have heating in the office building, so yes.
Okay.
Cool. We have the heater. All right, cool.
Yeah.
Okay,
Yeah.
we have some of our audience ask, hello, doctor here.
Hello.
Hello. And then some of them said, hi, Canada. Wow. Okay, cool. All right. So how are we going to run this session, Azim? So we divide it into some numbers of sections, right?
We're going to divide our session in few slots. So for the first 30 minutes, we will have a talk from Doctor. And the next session, we will have Q&A session from the questions that we already collected from our participants. And next part, we continue with the second slot, where Doctor will share another 15 minutes talk. And the final part is Q&A session again. And there's the closure after that.
Yeah, we also might pick some of the questions thrown by our audience here. Right. So guys, if you have any question, you can put it there. We will have you ask Doctor. All right. Okay. If you're lucky, you have named that. Okay. Hi, Dr. Canada. Okay, cool. All right. So I think we should give the floor to Doctor. So without further ado, I think the floor is yours, Doctor.
Okay, great. Thanks so much. Thank you, Hafiz and Hazim. And this is an amazing outreach event that you're doing, and especially for young people. So keep doing that. All right. So as you know, I'm Kundan Kadam. I'm from University of Western Ontario in Canada. And today I'll be talking about the topic, where are the Martians? So I'll approach this topic from an astrobiological point of view. So astrobiology means you apply principles of biology to the universe. So it pertains to questions like, how did life originate, and are we alone in the universe, things like that. So this talk, it's divided into two parts. So in the first part, I'll be talking about past and present. So in the past, did Mars have a life, or if there was a life, was it totally different from Earth? Was it a second genesis? And can Mars support life? Things like that. And in the second part, I'll be talking about some more exciting stuff about human exploration of Mars. So this is an old drawing from Percival Lowell. So this was done in late 19th century. So that time, well, the telescopes didn't have camera, and it was it's a picture drawn by hand. So at the time, there was a belief that there were canals on Mars, but it was basically a mistranslation from Italian. So in Italian, the canali means channels, and it's mistranslated into English as canals. But you can see these look like irrigation channels or something. And this is again a hand-drawn map by Giovanni Schiaparoni, and this scientist, Percival Lowell, he pursued this concept for a long time. So he actually indeed believed that there were Martians, and there were droughts on Mars, and there were these were irrigation channels by water. But we, of course, now we know that there's no artificial structures on Mars, but we do see this dichotomy, which is clear to see. So the northern hemisphere, it's very flat, and in the southern hemisphere, there's mountains and a lot of structure. So there is a belief even now that maybe in the past there was a sea and covering about 1/3 of the Martian surface. So this is about geography, but we are more interested in talking about life on Mars. So it comes in a lot of forms. So initially science fiction. So many of you young people probably don't know about this radio show. So this is a science fiction radio show called War of the Worlds. So in 1938, what these people did, they presented a drama as if it's a real news event. And the news event was that there was some explosions on Mars, and then there was some meteor crash in New Jersey, and some aliens came out of it, and they started shooting people with heat rays, and people, public panic. They started driving, and there were road traffic jams. So U.S. bans fake radio alarms. So that's the news article from 1938. And again, this is one of my favorite book series. It's called Mars series by Kim Stanley Robinson. So red Mars, green Mars, and blue Mars. So it talks about the colonization of Mars and its terraforming and long-term results. If you're interested in science fiction, check these things out. And recently, there was also some rumors or some fossils which were discovered in Mars meteorites. So meteorite is a piece of rock which is found on Earth. So what happens is, well, long time ago, Mars was impacted by a meteor or a comet, which dislodges the surface of Mars. So it lodges a surface of a piece of material from the surface into space, and it somehow lands on the Earth. So it's a very rare event, but it does happen. And in 1996 or so, scientists found that this structure, it looks like bacteria, but later on it was disproved that it's actually a mineralogical structure, so it can occur naturally. So this was a false alarm, and even Bill Clinton talked about it, but at the end it was it turned out to be nothing. So today let's start from the beginning. So let's see what life is. So something to be alive, how we define it is that the main characteristic of life is reproduction. So it should reproduce itself indefinitely. Heredity, so it's a transmission of traits. Growth, it should grow so that it can reproduce. It responds to the environment. It should have some cellular structure so that it can be in homeostasis, so it can maintain some environment inside its body. And it metabolizes energy, so it converts energy into work, basically, to do all these interesting things. And in case we find life on Mars, we don't define aliens in terms of where they are at present. We define them if they're related to the Earth life or not. For example, I'll talk more about it, but on the Earth, we have basically 3 big groups of life, which are domains, they're called. So bacteria, archaea, which are unicellular organisms, and eukaryotes. So this includes all the plants, trees, all the familiar life form that you're familiar with. But it's theorized that all of these came from a common ancestor, which is called universal common ancestor. So it shared some traits like a DNA-based life. So it has the same base pairs, A, G, C, T, nucleotides, adenine, guanine, thymine, and so on. And it has a water-based cell and a fat-based membrane, and so on. So all the living organisms are somehow related to this primordial organism. So in case we find life on Mars, we have to see if this is related to us or it's totally alien. And there are different hypothetical types of biochemistry. So the life on Earth is based on carbon. So that's the basis of life. But silicon is also very similar to the structure of silicon is also very similar to carbon chemically. So it can be an alternative basis of life. It's tetravalent. That means it has 4 ions. You might remember from your chemistry classes in school. And it can dissolve in hydrocarbon solvents, so like methane and so on. And it's cosmically abundant. So a lot of Earth's crust is made of silicon. So it's possible that somewhere else the biochemistry can be based on silicon. And indeed, even on Earth, there are these algae called diatoms. So here's a picture of diatoms. So these are very tiny plant-like things in the ocean. Mainly, they live in water bodies, and about 20% of the oxygen is created by these diatoms. So the funny thing is they have silicon exoskeleton. So they're made of glass on the outside. So they have a very interesting life. If you are interested, you can look more into them. So what can Mars tell us about life on Earth? So there are certain theories of origin of life on Earth. So one theory says that it's extraterrestrial, and some theories propose that it originated on the Earth itself. So panspermia, it means that life came to Earth from the outside. So there's random panspermia. That means life came through asteroids, meteors, and things like that. And directed panspermia, that means that life was somehow implanted on the Earth by some sort of aliens, maybe. And the terrestrial origin says it can be inorganic origins like water films on the clay surfaces, or it can be organic origins. And if it's organic, it can photosynthesize or chemosynthesize, so they can derive energy from light or chemistry to begin with. Yeah, so that's the how it originated. And if it's organic in origin, where did the organics come from? They can come from comets, like exogenous delivery, or they can come from processes on the Earth. And heterotrophic means that like just one organisms eat another. So, and funny thing is, we already have aliens on Mars, and they're called bacteria. So we have already contaminated Mars. So all these space probes that we send, they are not 100% sterilized. So this Curiosity rover, this is a selfie of itself. So it's created from stitched images, and it has about probably 300,000 bacteria on it. So they are not on the surface. They are basically inside of the instruments and in the shadowed regions, because if they're on the surface, the surface gets sterilized by the UV radiation. So Mars doesn't have ozone, and all the solar rays, they come and they penetrate the atmosphere, thin atmosphere. And on the surface, it basically sterilizes the surface. And how long will they live inside? They'll probably live about 10,000 years, so they'll live for a long time. But it's not a threat for contamination for Mars, because they're not reproducing. They're basically dormant in the Martian conditions. But in the future, if the conditions are right, they can come out and multiply and so on. So let's see what are ecological requirements for life. So firstly, you need to have energy, then light. If the life is similar to what we see on the Earth, then we need to have chemical energy, some carbon, if it's carbon-based. We need to have liquid water, which is the universal solvent, and we need to have certain elements for key reactions for metabolism, things like that. So in our solar system, most of these things are common. So energy is abundant. Photosynthesis can be done at 100 AU units, 100 astronomical units. So this is about twice the distance of Pluto. So chemical energy, it's possible to derive it from hydrogen, CO2, things like that. And we have carbon common in the universe, and these elements are also likely to be common. And what is rare is the water. So this tells you why discovery of water is such a big deal, because all other things are common and the water is rare. And let's see what are the conditions under which life can survive. So low temperature, we can survive, well, not we, but bacteria can survive at -15 degrees Celsius. Upper temperature is about 122, at which the protein starts destabilizing. So these are bacteria found in springs like Yellowstone National Park, things like that. Under maximum pressure, like Mariana Trench, which is the lowest point on Earth, there are still organisms there. Under low light, algae in the deep sea, they can survive at the light which reaches Pluto, so very low light. pH value, which is the acidity of the solution, if it's too acidic or basic, they can't survive. If there's too much salt, organisms cannot survive. And water activity is basically how dry the substance is. So this is the reason why your protein powder doesn't get decomposed in air, because it's very dry. Bacteria cannot survive. Then UV radiation and radioactivity. So this is basically a certain amount of energy per hour. So if the UV radiation is too much, it damages the DNA, and then the cell cannot reproduce, and it commits, destroys itself. So these are some of the limits of life. So if you want to find life like Earth, we need to look for conditions which are suitable. Now, these suitable conditions, especially for water, are found what we call is circumstellar habitable zone. So this is a zone around a star at which the water can be in liquid phase. You know, if you're too close, it boils off. You're too far, something like Mars, it can it basically freezes. So Earth is in just the right spot, and Venus and Mars, they have the potential to be to harbor liquid water, but right now they don't have it. So along with habitable distance from the planet, you also have habitable size within the Goldilocks zone. So this is like the good zone to have basically a thick atmosphere. So Earth can sustain thick atmosphere because it has sufficient gravity. If you don't have gravity, for example, on Earth's moon, water atmosphere there can be, it just disappears into space because the mass is not strong enough to hold on to that atmosphere. So Mars can have a thick atmosphere theoretically, but right now it's only about 1% pressure at the surface of that of the Earth, so thin atmosphere. And another thing about habitable size is that large planets can harbor a magnetic field, which becomes important also. So in terms of magnetic field, this shows you the Earth's magnetosphere. So Sun is very active. It keeps emanating charged particles, and it can also have what they call is coronal mass rejection. So these are charged particles emanating from the Sun. And if they encounter the Earth's magnetosphere, they are deflected along the magnetic field lines. And they're deflected along northern and southern hemispheres. And that's how you see the corona australis and borealis, which are the northern and southern lights. That's the interaction of solar particles with the Earth. So if you don't have that, these particles directly come to the surface and harm the living organisms, and they can also erode the atmosphere. So it's like two-way effects. Protection by the magnetosphere. Now let's see what types of biosphere we can expect. So these are basically sum of all ecosystems on the planet. So in type 1 biosphere, it's something like Earth, in which you have nice sunlight, it's photosynthetically driven, and well mixed, and gases are in non-equilibrium. What that means is if there is life at any particular part, you can see the traces in almost anywhere. For example, plants create oxygen, and you can detect it almost anywhere in the atmosphere. So it's well mixed. And then you can have type 2 biosphere, in which Well, on the surface, it can have no visible means of support for life, but it can be chemosynthetically driven. That means it's driven by chemical reactions. And the biosphere is stratified. That means it can be in certain regions, or for example, it can be below the surface in an ice in a watery ocean. And on the surface, you can just see the ice, so you don't see any signs of life. But below that, you can have a biosphere, possibly. So talking about satellites, most of the large satellites of outer planets can have possibility to harbor life. So Jupiter, the 4 big satellites, Io, Europa, Ganymede, Callisto. So you can even see them from a small telescope. If you haven't done that, please do so. It's an amazing sight. You can also see these weather bands on Jupiter. And on Saturn, Neptune, and Pluto also, it's possible that they can sustain life, because basically what happens is they have tidal effects. So the gravity of the planet, it squeezes and squishes the satellite so that there's internal heating on the satellite, and that can sustain liquid water, even though the satellite itself is outside the habitable zone from the sun. So these are 2 of my favorite satellites. One is Titan. So Cassini-Huygens mission landed on it not too long ago. And this is a picture from its surface. So it has a thick atmosphere, but it largely consists of nitrogens, and it has lakes of methane, things like that. Good atmospheric pressure. This is the only satellite which has a large atmospheric pressure. And another one of my favorite is Europa, which is moon of Jupiter. This Titan is moon of Saturn. So it can have water. So composition, it looks like it has, what do you call it? It has water ice surface, and there can be liquid water or even oceans underneath. So it can have large volume of water, and which is sustained by the tidal effects, being so close to Jupiter. Now, outside of our solar system, we have exoplanets, which are basically planets outside of our solar system. And they can be detected by various techniques. So here I list some of them. Radial velocity is watching for wobble in the spectrum of the star. And transit is basically looking for eclipses. If something comes in front of the star, you can know that may be a planet. There's direct imaging. You can take pictures of the star, and if the contrast is good enough, you can see the planets. There's gravitational microlensing, which is a bending of light by gravity. If the star is in the vicinity, it can bend the light. You can see it. And astrometry is small movement in the motion of the planet. Motion of the star itself. So you don't see the planet because it's too faint. You just see the motion of the star, and you can infer that there may be a planet around it. So far, you can see that there are about 3,000 or 4,000 planets detected, but none of them, some of them can be candidates for life, but life has not been detected on any one of them. But this is one of my favorite systems, and this is also very famous. It's called TRAPPIST-1. So it's around stars. So these are, so the sizes are to scale. So it's a very small M-dwarf star, so it's not very much bigger than the Jupiter, but it harbors 7 planets. So TRAPPIST-1b to 1h, and 3 of them are in the habitable zone. And they are very close to each other. If you're on one of these planets, you'd see another planet as big as twice the size of the moon, so the view would be very good. And the astronomers are there trying to find out if there are any detectable signatures of life on these planets. And one of the ways to detect life on such planets which are very far away, you cannot send any probes, is exoplanet spectroscopy. So you can have transition and transmission spectroscopy. So basically what happens when the planet transits, so when the planet comes in front of the star, a small amount of light passes through the planet's atmosphere, and you can analyze this light and infer what elements may be present in the atmosphere of the planet. So for this, you can imagine this is a very small amount of light. So you need to have very sensitive instruments for that. And upcoming James Webb Space Telescope will be more capable of doing that. And so far, the planets detected, they have been hot Jupiter, so they're like very massive planets very close to the star. So some of them have water vapor, but those places are not suitable for life because they are very hot, 700 degrees Celsius and things like that. So not suitable. So this tells you the Drake's equation, which tells you the probability of finding life on any planet. What do you call it? Any place in the Milky Way, basically. So n is the number of advanced civilizations which you can contact. R star is a star formation rate. Some of them harbor planet. Some of them have sustainable life. And on some of them, the life actually appears. And a fraction of them have, say, intelligent life. And only a fraction of them can communicate with you, yeah. And at the end, you have to multiply everything with how long do the civilizations survive. And this equation was, well, it's a hypothetical exercise done by Drake. And it's a famous equation, and it gives you basically between 1,000 and about 100 million planets with civilization, which you should be able to contact within our Milky Way. So since this is a large number, if you just point a radio antenna to the sky, you should be able to hear them, but we don't. So this is a famous question asked by Enrico Fermi. So one day they were, the scientists were discussing about this problem, and his question was, where is everybody? So this is funny, and that is true. Why don't we see signals from aliens? So this Institute Search for Extraterrestrial Intelligence, SETI, which was formed in 1984, it was a small project of NASA, but then it got bigger and got its own funding. So they hear for radio signals from aliens, basically. So this is 300-meter Arecibo telescope in Puerto Rico. So they use instruments like this. Unfortunately, this telescope is out of commission now because this one of the cables failed, and now it's totally destroyed, unfortunately. But they use other instruments or radio telescopes. All right, let's come back to Mars now. So the big question is, does Mars have water? You know, so definitely in the past, we see evidence of liquid water on Mars. So this is so here you can clearly see in Nandi Vallis, you can see erosion caused by flow of water, and there are other examples of enormous what do you call it? River valleys, networks, deltas, lake beds. And I mentioned something about ocean hypothesis, which says, well, about 1/3 of Mars was covered by oceans, at least at some point in the past. So 200 billion years ago, Mars was indeed hot enough to sustain liquid water. So you keep hearing news like there's water on Mars, but how do we actually know there's water? So this is the Mars' satellite, which is an orbiter. So this is a satellite which orbits Mars, and it keeps sending. So this was this reached Mars in 2005 and start gathering data. So this large antennas, they're actually radar booms. So it has a 40-meter long antenna. It sends radar signals to the surface and sees what comes back. And what it sees is something like this, you know. So it's a ground-penetrating radar, so it can go subsurface. So this is a North Polar Cap. So these are the polar regions. So you see ice on the surface, but below the ice, you see traces of water. Hafiz?
Yes, 5 minutes more before we go to for Q&A session.
Oh my God. Yeah. Okay. I'll try to make it quick. I'll try to make it quick. Let's see. So through the radar and so on, we know there's ice, and so this is the polar cap during summer and winter. Yeah, so most of this ice is CO2 ice. This is not water, but there is some water ice below it. And by the Phoenix lander and so on, you can also see water on the surface. So there's definitely water. Today it exists as ice, a water vapor, and beneath the polar caps there's water. If you liquefy all the water, it can cover the whole planet up to a depth of 35 meters. So it's a very substantial amount of water. So let's move. So far we have sent a lot of missions to Mars, but there's no evidence for life. We found water, we didn't find life. So that's the mission Perseverance. That's what it was supposed to do. So it will land in Jezero crater. So this is the crater, and you can see there are some inflow channel structure there. There's outflow channels, and there's this delta. And in the past, the crater looked something like this. So it harbored a lake. So this is an artist's inception. It probably had a ice surface on it. So it will land right here and try to look at signs for life. So it has several scientific instruments, but I'll mention two of my favorites. One is Sherlock, which is basically is Raman and luminescence spectrometer. So what it does is it will look for biosignatures. So this instrument, it doesn't need to touch anything. So it's located in the arms. So it will hover in one of something which is interesting. So it shoots a laser beam at the target and analyzes its spectrum. Yeah, and through analyzing the spectrum, it can look for biosignatures if there's carbon, things like that. It's a UV laser, and if it finds something really interesting, it has a sample caching system. So it's a robotic arm. It has a drill, so it will drill down and collect a rock sample, which is about the size of a lipstick. So it's 10-15 grams of material. After collecting, it will take measurements, images, and it will seal it. And the most exciting thing is it will drop it for retrieval in the future by later missions. And there are plans in 2031 because you can't take sophisticated instruments to Mars. You have to fit everything on the rover, and their energy requirements. You can't have a large amount of energy spending on the analysis. So the best thing you can do, other than sending humans to Mars, is return these samples to Earth so we can analyze them in exquisite detail in the laboratories on Earth. So this is what the rover will do. It will collect about 42 samples, and hopefully in 2031, there's plan to return the sample to the Earth. And after that, we can see what we find, and maybe we'll find some traces of life. So with that, I'll end this first part of the talk. And in the second part, this is a preview. I'll talk about the future. So with that, I can take any questions if there are.
Cool.
Okay,
actually, a lot of information has been shared.
Yeah.
Right.
So I believe that's the start of our session for tonight. Hopefully, you guys watching with us understand the basic principle first. Understand what is life, as Doctor already mentioned it, and also a few missions. That Mars Sample Return mission, and also the Sherlock. The nickname is quite catchy, Sherlock. So it's to detect organic compounds on Mars soil.
Yes. So I really need you guys to really focus on what has been said by the doctor. So it's important to understand what actually life means and how it originated and how scientists collect samples to define life. So we have numbers of questions. We collected.
I think we're going to start now. Okay.
Yes. I think
okay. Before we go to the question, I just saw a few comments in the YouTube channel. They said, "Is Dr. Kundan an astrobiologist?" Yes, Dr. Kundan is an astrobiologist. That's why we invite him tonight to talk about is there life on Mars.
So some comment is that I'm basically a theoretical or computational astrophysicist. So biology is not my strong trait, but I'm basically a professional astronomer. So I mainly study planet formation. So how planets like solar planets, such as in solar system, formed from the primordial dust and gas. So
Okay.
Cool.
Thank you, Doctor. Okay, so we're going. We're going for the first question. Okay, this is the first question is from Sabrina. Okay, the question is, what is the main purpose of discovering Mars? Is it to find a suitable planet for humanity, or just for the sake of learning new things about the solar system? Okay.
That's a good question. So, shorter answer is both. So we humans are curious species. We need to discover things. But more interesting is the prospect of colonization, which I'll also talk about in part 2. So we have only one planet so far, and if something goes wrong here, that's it. The humans are basically go extinct. And in the future, there can have two possibilities. Humans can be a star-faring civilizations in which we have a future on other planets, or we can just live and die on the Earth. So which is more exciting? So probably second part is more exciting. And in the past, we have come very close to destroying the Earth. For example, during Cold War and so on.
Yes.
We are just moments away, and probably just one man saved the Earth from nuclear disaster. So if we don't want future like that, we need to go to other planets, and Mars is probably the first step.
Cool.
Okay.
So we are the curious species. So that's why we go out and find a new place to live. Yeah, to enjoy.
Yeah.
All right. Cool.
Okay.
That's a good question.
The next question.
All right. The next questions come from Grace Marian. What will happen if NASA found another form of life on Mars? What are going to be the next things?
Yeah, that's also a good question. So I think first thing is we really need to make sure that it's actually life. It's not contamination by Earth organisms, things like that. So that will take some efforts. And second thing, once we find it, we have to. So the first question we ask is it the second origin, or it's somehow related to life on Earth? So it's possible that life originated on either Earth or Mars, and then it got transferred through the asteroids. And in either case, even if you find living organisms or some bacteria that were living in the past life, in either case, it will be a very big discovery. It will mean a lot for human species. So
it's quite difficult to differentiate them. I mean, it is contaminated from Earth, and to differentiate the Earth microbes and also the Martian microbes.
So I think these days you can do genetic analysis. So you can see how the organisms are related to one another. So that way it becomes possible.
Is there any expectation from the genetics from Mars? Is there any going to be a difference?
So short answer is we don't know. Because the thing is, we have
a mystery for all the scientists.
I'm sorry, Ivan.
So it is still some there's
ambiguity.
Very mysterious, ingenuity.
Ambiguity. You can say that.
Form of life on Mars, if there's any microorganisms live or alive there.
Yeah, that is true. We don't know, and that's why we send missions like Perseverance, and we need samples back so that we can know for certain.
Okay,
cool.
Okay, I think for the next question, I'm going to pick a question from the YouTube channel here. Okay. Before this, Doctor already mentioned about the Goldilocks zone. Okay, so this question is related to that from Sharman Lai. Okay, the question is, how does Mars has life? It is not in the Goldilocks zone. Okay.
Yeah, that's a good question. So Mars doesn't have life now, probably, or we don't know. But in the past, about 2 billion years ago, Mars did have a large amount of liquid water. And that's the same time when life also originated on the Earth. And it had liquid water because at the time, in its geological history, it still had volcanic activity and so on. The atmosphere takes some time to erode by the solar radiation, things like that. So there's definitely water. So the question is, was there life? So that's what we're trying to see.
Okay.
All right, cool. All right.
So the next question.
All right. Okay. I think I'm looking at this. Is there any questions to be asked from the YouTube or Facebook? So you guys, if you have good questions, just write it down there. Okay. Let's go to another question. I think this one will be like a meteorological question. Okay. That's a good question actually. From Ryan Farisha binti Nasir, are there any clouds on Mars? We know you can expect.
Yeah, definitely. There are clouds on Mars, and interestingly enough, they are water vapor clouds. So
water vapor.
Yeah, they're very thin clouds. They occur high up in the atmosphere, but it's very small amount of water. You can see wispy clouds. Altitude of 15.
Can it be seen from, telescope, or must be seen through like MRO or satellite around Mars?
Yeah, definitely from the satellites, but from the Earth, you'll need very powerful telescope. So, well, maybe the next question is, does it rain on Mars? But it probably does not.
Yeah,
The water vapor probably just so the what do you call it? The vapor pressure on the surface of Mars is less. Well, the pressure on the surface of Mars is less than the vapor pressure of water. So what that means is water can exist as solid, but as soon as it's liquid, it just evaporates as gas, basically. So it cannot sustain as liquid. So it can probably crystallize in small crystals. I think that's a phenomenon. In polar regions maybe are the regions of shadows, but not as water droplets.
So you couldn't expect any snowfall for Christmas?
Yeah, unfortunately, no, not like the snowfall on Earth.
Yeah, all right, cool. Okay. Any question from any Facebook or anything?
Yes. I saw there's not much, I think, from Facebook. Okay, yes, we have a question from Facebook here. I noticed one. Okay. From Uyan Liang. Okay. So the question is, isn't Titan a better candidate to examine for alien life? Okay, that's the question. Now we go to search about alien.
Yeah, that's true. Well, we don't know, and well, few things. We have sent Cassini-Huygens probe at Titan, which is the satellite of Saturn. But the thing is, it's very far and it's very difficult to send probes there. So we have sent one, and it's also very cold. So it has temperatures of negative 100 degrees Celsius and so on. So you have methane and hydrocarbons. They flow as what do you call it? Flow just like water there. So the temperatures are very cold. So probably not water-based, or if it's water-based, it might be somewhere subsurface. But that's one of the primary candidates still, because it has hydrocarbons.
Okay, I think this question will be almost the same. Like, I'm not sure, but let's bring this question up from Facebook, from our friends. Okay, she's in UK. From Farah Zainal. Okay, thank you, Farah, for the question. As we know, Europa, it's made out mostly of ice. NASA has an interest before with Europa because under the ice we can examine water. Why to focus now more on Mars?
Yeah, that's a good question. So, well, if we had infinite money, maybe we can send probes to every possible place. But money is always difficult, and technologically, it's also difficult. So on Europa, what you have to do is you don't have to land and drill, but you have to drill through like kilometers of ice to get to the liquid ocean if it's there. So a lot of things can go wrong. And if you look at the history of spacecrafts to Mars, almost 50% of them failed. And it's also very expensive. So we choose the lowest hanging fruit and send things to Mars. And Mars is also a very interesting place. So.
I like you using the low hanging fruit. Mean that if you go to Europa, and then you need to have a submarine there, right?
Yeah, basically. So now we have Ingenuity, which is basically a helicopter. There you need to have some drilling equipment and then send some wire or wireless submarine, as you say.
Wow. They're going to be like technological challenge for human.
Yeah, it's very challenging, but it's like job security. You know, if you're young people and you're interested in this, you can spend a lifetime developing these technologies and get ahead. So.
See, okay, guys, okay. If you focus,
who's going to be the next submarine engineer for space exploration?
Yes.
Yeah.
Wow. Quite interesting. Okay.
Yeah.
Okay. So how much time do we have before we go to the next?
Okay, we have another 6 minutes about for the Q&A session.
All right. So I think we can go to another question. Okay. Okay. I think.
This question from Isma. I think you can up.
Yeah, from Isma. Okay.
Okay, from Isma Adam Muhammad. The question is, if humans go to Mars, how long can we live? Okay, Doctor, I believe it is not the same as how we live on Earth, because Mars we cannot simply live there without any proper biospace or by your environment that friendly with us. Okay, your explanation, Doctor.
Yeah. If you go there right now, you might live 30 seconds because after that, the liquid starts evaporating in your bloodstream, things like that. But I think the question is, let's say if you form a colony there, how long we can survive? So
yeah, the longevity of life.
Yeah, so using Martian resources only, if you set everything up, you can live there indefinitely. Basically, you can mine what do you call it? Elements from Martian soil and set up greenhouses to do farming, and you can have an indefinite colony there. And in case you terraform Mars, so the atmosphere, it will take some time to deplete. It will take like 100 million years or so. So you can live there for a long time if you transform Mars also.
So does it, I mean, is there going to be any effect because of the difference of time relatively, and also the year also different, the day also different, the hours is different. So does it going to be...
yeah, so you have to adapt. I think the length of the day is not very different. It's only 25 hours compared to 24.
Yeah.
So you get... So people keep saying, I wish I had 25 hours so their dream will come true if they go to Mars. And the length of the year is, I think, 700 something days. So your birthday will be very infrequent. It will be a big event, I guess.
Yeah.
So, yeah, other than that, there are no like, what do you call it? Special relativistic effects, like in presence of a black hole or something. It's nothing like that. And one thing is that the signal takes 20 minutes or so up to get to the Earth. So if you want to talk to the Earth, just the signal travel time, you need to consider that. So you probably can't have live chats with your relatives on Earth.
No, it's not just simple text. Hello. You need to wait for 20 minutes to reply hello again. No, we don't do that.
Yeah, unfortunately. Yeah.
I think there will be like encryption message, and then send it within 2 seconds. Or maybe we're gonna develop new technology for the communication. Doesn't know, using laser or what.
So the speed is set by the limits of physics. Speed of light. So it's you cannot break it basically. So it has to be 20 minutes.
Still 20 minutes.
Yeah, I mean, not well. It depends on the where the mass is exactly in its orbit.
Yeah.
If it's at the opposition, it will be a couple of minutes. If it's farther away on the other side of the sun, it will be much longer. But you cannot escape that. It will always be there. And it's like you message your friend, and then you go have a breakfast, and then you get reply back, and then things like that. So.
Wow.
Okay.
All right. Let's see.
Okay, I think we have time for another question. One more question before we proceed for the next slot.
Next question. I think you can pick one here from Adila, right? Okay. Okay, from Adila Atira. A lot of movies regarding Mars have been portrayed. Does this mean there is a chance that one day human being will live on Mars?
Well, I hope so. If there's no chance, then I'll be very sad, because if we don't go to Mars, that means we don't leave Earth at all, because Mars is the closest place, and it's very suitable compared to rest of the things, as we'll see in the second part. So I'd like to...
Doctor, do you think within our lifetime we can see people settle on Mars?
Yeah, very possibly. If you're young, there's a good chance that you can go to Mars. I'll talk about that also. And if you're not young, there's a good chance that your kids can go to Mars.
The key point is you are young.
Yeah,
you need to be young first.
Depends on your definition of young. So.
Okay, Doctor, a quick question for you. Okay, if you have the opportunity to leave Mars and settle on Mars, do you want to go there?
Oh man, that's a difficult question.
You should ask him at the end of the session, Azim.
Yeah, so if there's a return flight, so then in that case, yes. If it's a one-way mission, then I'll have to say goodbye to all my friends on the planet, and I cannot even video chat, so that'll be difficult.
Doctor, even return flight also takes you 2 years to wait, right?
Yes.
Yes. It's not that easy to wait for return flight. Okay, good. I think
Alright.
have a
Yeah.
good
Okay, I
theory.
think we have done for the first session for the first slot. Okay, thank you so much for the question that we already answered by Doctor. Okay, before we go for the next session for the second slot,
Okay.
I think we should have a commercial break first. Yes, commercial break first. We give time for Doctor to rest a bit,
Drinks.
and
Yes.
we meet again soon.
Yeah. Let's watch it.
نعلن نجاح وصول دولة الإمارات في مدار كوكب الأحمر. اللهم لك الحمد، اللهم لك الحمد، اللهم لك الحمد.
Sah. Alright.
Okay, we are back
Coming back
for the second
we are
session.
back. Yes. Alright. We are feel energized after watching all the
Yeah.
successful mission landed on
Yeah,
Mars.
we have the first one from UAE, the Probe Hope,
Yeah.
and the second one we have from China, Tianwen-1, and the latest, yes, of course, Perseverance.
Perseverance. Yeah. Now we are waiting for the Ingenuity to fly. Right?
Yes. Yeah.
There we are
Can't
looking for
wait.
that moment. Yeah. It's gonna be like a historical moment for us. Okay.
Yes, definitely.
So
Okay,
now,
Doctor. We move on for the second part of this discussion. Okay, the part 2 is the future. What is the future of Mars? Is there any chance for human beings going to live on Mars, or are we going to do something like Matt Damon had done in
terraform.
the movie? Yeah, terraform. Plants. Plant. Is there any chance that we can plant something on Mars? Okay.
Yeah.
Okay,
Let's
Doctor.
hear to the doctor.
Yes.
Okay, great. Thanks. All right. So in the second part, well, the assumption is that humans will be the Martians at some point, and I'm very excited to talk about it. So, well, first thing you need to know is that before going to Mars, we need to go to the moon, because moon is very close to the Earth, and it's like running a marathon before running a mile. You know, you cannot run a marathon before running short distances. So advantages of moon is that it has very low gravitational potential. So you can mine things on moon and then send them to Mars. You know? So it will be easier, cheaper, and it's only a 3 days trip to moon at any time of the year. But if you have to go to Mars, the launch window occurs every 2 years, and it takes from 6 months to 10 months to get there, depending on how powerful the rocket is. So considering that, we first need to go to Mars, definitely. Go again, basically. So that reminds me again of science fiction. So if you get time this weekend, watch this movie. It's called The Moon. So it's about what happens when you send only one man to the moon, one person to the moon. And another one of my all-time favorite books, maybe in the top 10, is The Moon is a Harsh Mistress. So they have a lunar colony, and they try to rebel against the Earth. So it's an interesting story. I should read it. Okay, so journey to the Mars. So this won't be an easy journey because it takes a long time, 6 months or so, and we need to shield the occupants from the space hazards. So what are the space hazards is that you have cosmic rays, which are energetic particles coming from the galaxy. You have UV rays, which you can protect easily, but then you can also have solar energetic events, which can bombard the spaceship with energetic particles also. In addition to that, although there's a small probability, you might need protections from small meteors and small particles like that. Radiation shielding, of course. And it's possible to use like food supply and water surrounding the astronauts, or some instrument which can act as a shield, but it's not easy. And it won't be a single ship. It will be like a fleet of ships, like Battlestar Galactica, because in case something goes wrong, you don't have a single ship. And before sending humans, you need to send robots to Mars to set up the habitat, things like that, so that they don't have to pitch their own tent, so to speak. And another thing, costly thing is that you can't take your return fuel with you. You have to make your own fuel on Mars. So we'll talk about that also. So next challenge is surviving the microgravity, during the transit as well as on Mars. So Mars has some small gravity on its surface, which is okay. It's not as small as the Moon. It's about 1/3 of that of the Earth. But during the travel, it will be very difficult to sustain gravity, because in science fiction you can have these centrifugal ships, and at this point they're very hard to build. You'll have conventional ship. So the microgravity, it has a lot of effects on cardiovascular health. So blood is pushed upward towards the brain. It can affect brain, eyes, neurological functions. And another thing is that your muscles atrophy if you don't subject them to gravity. So you see these astronauts exercising on their bikes. Exercise becomes important. Becomes more important if the journey is so long. Another hazard is the entering the atmosphere and landing. So you probably have seen this video, 14 Minutes of Terror, when like a robot lands on the planet. Imagine if the ship is filled with 100 humans. How difficult or how stressful that event would be. So in that case, you need to have redundancy. So Mars has a thin atmosphere, but it's enough to make the spaceship hot. So you need some kind of heat shielding for the ship. And at the end, you need some kind of parachuting system or retro rockets. And that system needs to be foolproof, in the sense something happens to one rocket during the entry or on your way there, the other rocket should function. So there needs to be some redundancy. So it will be very challenging. And if it's a parachute,
sure you don't want to crash on Mars, right?
Yeah, exactly. With 100 people, or especially in the beginning, that will halt the entire human mission to Mars. So living there, so the surface conditions are harsh. As I said, there's a lot of UV radiation. There's no shielding because of atmosphere or magnetic field. So one possibility is that you can live underground, like in bunkers, like shown here. You can. It's challenging to live on the surface, also because the atmosphere has low thermal inertia. What that means is the day and night fluctuations become very large, like up to 100 degrees Celsius. So at night it gets as low as -98. In daytime it can get 20 degrees. And the thing is, when you have such high fluctuations of temperature, you can't afford for the energy to fail. So this shows like a artist's depiction of a colony on Mars. So you have some habitats and a lot of solar panels, and you can't have interrupt the power supply, because if it goes out for a few hours, you'll basically freeze to death. So one big hazard on Mars that it can have dust storms. So the wind velocities are very high there, but funny thing is the atmospheric pressure is so low that if you put Matt Damon on Mars, he won't get blown away by the wind, although there are high velocities.
I know.
So the prospect of Martian is out of the window. It's based on not reality. But so yeah, basically you can't afford to have only solar panels, because they can get blocked for months because of dust storms. So you need to have backups, for example, nuclear power or something, which you need to set up before sending humans, or need to have some provisions of it. And I found this cartoon online which says, 3 steps of exploration while sending humans to Mars. So in the first steps, what you'll need to do is you'll need to wear a spacesuit, just like in space, because of Martian harsh conditions. So it will be pressurized, it will have oxygen, and humans can do in 1 hour as much as work as like a machine takes for hundreds of hours, things like that. So humans can really make the work go very fast. And another thing is that you probably cannot discover fossils unless you send humans there. Because for example, if you have a robot, you send it to any place on the Earth, it's very hard to find fossils, but scientists still find them in plentiful. So you need humans to determine for certain if Mars ever had life.
So our eyes much more better than the robotic eyes, right?
I'm sorry,
camera.
what?
Our eyes is much more better than the robot camera.
Yeah, that is true, and our brains are much better also. That's the main thing. Farming in Mars is also very challenging because the soil has perchlorate, so which is basically a toxic salt. So as you saw Matt Damon just mixing his poop with Martian soil to grow potatoes, it's not that easy. You need bacteria or something to get the perchlorates out of the soil, and some greenhouses to warm it up, things like that. So it's a challenging problem which we have not solved yet. Scientists have mimicked Martian soil with certain elements, and they try to grow plants out of it, and apparently the plants keep dying. So
keep dying.
They don't survive after a certain time. So it's a problem to solve. So in the second step, we start terraforming Mars. So you can. So here you see some factories in the background which emit some super greenhouse gases like methane and so on. And then 3D printed habitat. And here you can see the suit that these explorers are wearing. They're not as, they don't look like spacesuits. They look like firefighters uniform, So it's like less protection. You can do that. And it will take about 100 years only if we try, 100% try. To change the atmosphere theoretically, So in 100 years, you can have atmosphere to do this. So it's possible in near future. So you can do this using the greenhouse effect. Basically, you have these gases which trap the right light, which will be reflected onto the space, So it's the same effect that happens on the Earth, but on the Mars, it will be beneficial because it will warm up the planet, make the atmosphere thicker. And after a long time, it may be possible to grow plants on Mars, So it's maybe genetically engineered. We'll have to see if there's life on Mars or not. If not, we can introduce our own life. It will be possible to have temperature control due to greenhouse, so you can have liquid water. And here you can see the explorers. They're wearing regular clothes, but you'll always need to wear oxygen mask. It probably won't be possible to live without oxygen there. So SpaceX has several plans to go there in near future. So Elon Musk, he was saying we can go there in 2022, which is next year. I don't think that will happen. Maybe in next 10 years, though, it looks very promising, and I support his mission. Sorry, I read the wrong message from 1 minute. I think that's a long time ago. So with SpaceX, I think if you watch Elon Musk talks, he says that there are 4 things which are important, and they basically all revolve around cost. So when you build a rocket now, like Saturn V or so on, which was used for Apollo missions, you basically go to the moon, but you throw everything away. You throw the entire rocket into the ocean, which can be retrieved, but it gets destroyed by the sea salt and the elements. So it's basically like instead of buying a plane ticket, you buy a whole plane and throw it away after one flight. No one will ever do that because it's too expensive. So you need to have reusable ships, and then you need automated docking system and refueling in space, and then you need to make your own fuel on Mars. So basically Mars has water, it has CO2. So combining that, you can make water, which is H2O plus oxygen. And you need oxygen as oxidizer for your fuel. So you can have methane-based rocket ships or engines. And good thing about Mars is that you don't need a booster rocket. So on the Earth, you probably know that everything will sit on a booster, which will return back to Earth. But since Mars has a shallower gravitational potential, you don't need boosters. You can just land this rocket on Mars, refuel it, and landed back. So SpaceX has very exciting spaceship designs for that. So check them out if you're interested. And this Perseverance missions, for the first time, it will test human, spacesuit materials on Mars. So it has this instrument on which there are different materials, polycarbonates, which will be used for glass, Teflons, which is a flexible material, and so on. And it will test these materials, how they react to the Martian atmosphere in situ, so at that location. And if something goes wrong, it will analyze that with its the Sherlock instrument, and we can know that, well, some material works better on Mars, and we can improve on this. So this is clearly aimed at human missions in the future. Cool. Another instrument which is aimed at human exploration is the MOXIE, which is basically a test of oxygen, oxygen production on Mars. So basically what it does is it has, the sensor assembly, it has a pump, so that the pump creates a high pressure environment, and it goes to SOx assembly, which is like solid oxide electrolysis unit. So it's basically a reverse electrolysis process. So it takes CO2 from the atmosphere and converts it into CO, carbon monoxide, plus oxygen. So it needs more power, so all the other instruments will be closed, and it will use batteries. But it will test how efficient is this process of producing oxygen. So this is, again, machines don't need oxygen. So this is, again, clearly aimed at human spaceflight in the future, or human missions to Mars.
So are they going to contain the oxygen generated from the MOXIE, or just release it at the Mars atmosphere?
So I think they will test what the efficiency is and what the rate is of the oxygen production. So it produces like 6 grams per hour, 98% pure oxygen. So they'll see if that actually works. So it works in theory, if it works in real life, because you can't take chances with humans. If something goes wrong, everyone will die. So you can't have that.
So some people have a naughty word. They say that the Perseverance is farting oxygen.
Well, humans can't do that, but we can fart greenhouse gases, so that's a good thing on Mars. So I think I have some time. A few minutes.
Yes.
Yeah, we have 1 minute more.
Okay, so very quickly. So this picture shows you. So this is the sunset, and this is the midday sun on Mars. So it's exact contrast on what we see on the Earth. So this happens because of the fine dust. For the exact same reasons that the sunsets are red on Earth and the sky is blue. So what the dust does is it scatters the sunlight. So during the daytime, you see the scattered light, but when the column depth of the atmosphere is very large in the evening, all of the red lights get scattered, and what you see is the blue light. So this will be a very eerie view if you step foot on Mars. Just to remind that, we focus so much on Mars. Well, don't forget our humble planet. So this is like the pale blue dot picture from space taken by Cassini spacecraft. So this is Saturn from the far side, other side, and this small dot is the Earth. So this reminds you that how insignificant we are. We live on a small planet on its surface, and we should be grateful for that and try to go to other planets and live on their small surfaces. So to end the talk, I'd like to end with the definition of perseverance. So it says it's the continued efforts to do or achieve something, hopefully meaningful, despite difficulties, failure, or opposition. So in your life, I think almost everyone faces difficulties, failures, and oppositions. But if you stick to your goals, and if you be the hero in your own life, you can become a scientist if you want. You can analyze samples, you can plan missions, you can be an engineer, design instruments and rockets, things like that. And hopefully within your lifetime, if you put your mind to it, you can be an explorer, set your foot on Mars and be a Martian yourself. So with that, I'd like to end the talk and this is especially for the young people. They can do anything they want. So with that, I'd like to end the talk, and I can take any questions if you have. Thanks.
Cool. I think we have a lot of information right now. All the new things we learn about Mars, the soil, and our capability as a human. And I like when Doctor ended the session with the perseverance definitions, right? Even though we know sometimes it looks like impossible, but we try to make it possible. That's human, right? Okay. I think this is the best time now for the question, Azim.
Yeah. Okay.
Okay.
All right.
So
yes, I think I want to take a comment a question from the YouTube comment. Okay. Previously, Doctor already said about the threat or that might have on Mars. Okay. This one is a question from Nur Azza Sirajuddin. Okay. She said, how about meteor? Okay. Is there going to be any threat from meteor coming from the outer space entering Mars? If we are on Mars, we are going to live on Mars. Is there going to be something like that?
I think in terms of natural disaster, meteors are pretty low on the list because the probability of them striking us on Mars is about the same as them striking us on the Earth. The difference is that Earth has a much thicker atmosphere, so most of the meteors just get burnt during the entering. But Mars still has a sufficiently large atmosphere so that the meteors are not a problem. But what is problem is that the solar radiation, cosmic rays, energetic particles like that, and natural disasters like dust storms, which can affect humans.
Okay.
All right.
For the next question, Hafiz.
Okay, the next question, I think it will be related. That one will be the hazard from outer space. Let's see what actually happening in the planet itself. Okay, is there this question come from Sufi Shami bin Sofian? Is there any natural disasters on Mars, like a landslide or earthquake? I think earthquake, is it possible?
Is it
Marsquake?
Is it we going to call earthquake or Marsquake?
Marsquake.
Marsquake.
So there's
volcano eruption.
So there's very weak evidence. So Mars is not geologically active. That means it doesn't have active volcanoes or plate tectonics because of its small size. It cools very fast on astronomical timescale. But there's weak evidence that there can be some Marsquake, but they will be small in magnitude. But in terms of natural disasters, as I said, the dust storms, they can block sunlight for months. And if you're relying on power or a significant amount of power on solar panels, on a robot, it can go dormant and it can reboot after 6 months, or you can just forget about the robot. It's just a robot. For a human colony, you cannot take that risk. So that's a big risk. So you need to have backups and backups for backups. And the second risk may be microgravity. We don't know how that will affect humans, children, growth of living organisms, if that will have any negative effects for that. More specifically, I think another thing I didn't talk about is that dust on Mars is very fine. So it's like talcum powder, and when if it reacts with moisture, like something inside the lung, it can form crystalline structures, and they can be cancer producing. So it can be very hazardous if you inhale the Martian dust. And it dust gets everywhere, basically, if you come out from a spacewalk, things like that. So it will be hazardous environment all times.
Okay, I have one question just want to ask, because just now Doctor did share about the two photos about Mars environment, the blue and the red one. Okay, that means we're going to see only two colors, right? Blue and red. How does it affect our psychology? We normally on Earth, we all see multicolor, colorful. Green, red, yellow, blue, white, any pink and everything. So now only blue and I think orange. Red. So how does it affect our psychology?
So I think you will be able to see some colors because this is like the color of the sky and color during sunset. But that's a very good question that for human missions, how that will affect psychology. You need to have psychologically stable, but even then, to live in confined spaces with strangers and then not have contact with families and then there's this uncertainty if the mission will be successful or not. So it will take its toll, at least initially when the things are uncertain. After that, I think even after that, I think if someone tries to move to Mars, so as Elon Musk says, maybe in 20, 50 years, so a trip to Mars will be as expensive as a house, basically. So it won't be cheap, but people will be able to afford it, and there'll be enough people to want to go there. And maybe you can get sponsors, you can say, hey, I'll work for you for 2 years, I'll dig ditches there, I'll set up your instruments, and you can pay for my trip. But even then, you'll have to leave everything behind, basically everything everything familiar, dogs, trees, simple things that you enjoy, view out of the window. So it will be psychologically very challenging.
Yes. Wow. I don't know how to, explain it when you need to leave everything behind.
Yeah, but I think that's the challenge of exploration. In old times, people left their family behind to discover continents. They took dangerous trips via ships, which sank during a sea storm, things like that. But there are still brave people out there, and that's how humans are. Some people are brave. So
we salute all of the explorers.
Yeah.
Yes.
Okay. So next question, Azim. So which one? From where?
For the next question, we have from Muhammad Iskandar bin Muhammad Hafizan. The question is, why did humans send rovers first, not human?
Yeah. So it's a good question. So, basically, rovers are cheap, and they're not as valuable as humans. So, as I said, if something goes wrong during a human flight, it will halt the entire mission, entire future plans. But with rovers, they're expendable. You can send 10 of them, even 9 of them die. It's not a disaster. It's costly. But again, we sent rovers in the past to test what's going on Mars, because initially you don't know anything. Then you send robots and instruments to see how the atmosphere is, how the surface is, or what are the conditions there, atmospheric pressure. So theoretically, you can calculate some things, but to know exactly what's going on, you need probes. You need instruments. So that's what robots give you. And I'm thinking before even human missions, they will send automated landing missions, and robots will unfold. They will unfold habitat, and after that, humans will go after everything is tested. Okay, because with humans you cannot take chances. No one will go there if there's a 50% probability that you'll die. Very few people.
Yeah.
So.
Yeah, the risk is very high.
Yeah.
Okay.
Very high. It is on stake. Okay, so we have one question here from ADL-Apadilagit. Why there can be a possibility that Martians live on Mars when there is only 1%, 0.1% of oxygen?
Yeah, that's true. So right now there's very little oxygen, and the conditions are not suitable. Like water just evaporates. But 2 billion years ago or so, we know there's evidence of liquid water, and maybe oceans, even large bodies of water. And life there can be chemosynthetic, or it can live in thermal vents, like in deep ocean. It can derive energy from chemical processes and thermal processes, and not depend on the exact same reactions related to oxygen that we see on the Earth. And even on the Earth, we have extremophiles which live in these extreme environments. So it can be related to those organisms.
So did you say that the life is possible there, even though the situation, the environment is harsh?
So according to me, it's possible that there was past life at some point. It's possible, but we have to find it. So today, if you ask me, if I have to bet on something, I would say today there is no life on Mars. Unfortunately, although this name of the talk is where the Martians, they're not there. Maybe in the past, but in the future, I'm hopeful that we can make that planet our own.
Okay. All right, Dato', we have, I think, some a comment here. Maybe you have thoughts on, might be you want to share something here. Okay. From the Facebook, if we found any life there, especially human-like, that organism must be powerful and have ability to resist few kind disease like radiation and etc. So it might be. Yeah, what do you think, Doctor?
So human-like, I'm assuming that human-like biology, but microorganisms. So it's pretty certain that there are no macroorganisms, like no organisms like the size of dog or something which are roaming around Mars. That's certainly not true. We know that. But if imagine if there are microorganisms and they're related to humans or something, so one possibility, they had to be extremophiles. They need to be living in these extreme circumstances. And so we can learn a lot about them. And if they're related to us, well, there are additional risks associated with that. Can they infect humans? So they probably won't stab us with knives or shoot us with guns. But there are other ways in, advanced threats which living organisms can affect us, like not just like explorers which go there, but if you bring back something like a virus that can be very dangerous. So we need to take these things very seriously. So we need to make sure that there's no life right now there. So.
Okay.
So even microbes also can affect us if we bring them back to us. We don't know yet what's going to happen, right?
Yeah.
Yeah, that's true. So yeah, if it's on the surface, it gets sterilized by UV radiation, but it can be subsurface, things like that, or it can be extinct life, which is just like fossil remnants. So we need to handle these samples with care. And I think that's what scientists are doing.
To contaminate Earth with another viruses or
okay, let me be clear with that. It's not going to happen in the sense there's very small probability of that. It's minusculely small, so you can disregard that as well. But in any case, we need to treat Martian life with respect, with native species, and we can learn a lot from them. Not just second origin of life, but how life originated and how can we develop medicines and things like that. So they're probably not going to affect us directly, but I guess that was the question: can they stab us? Can they do something? So yeah, they can probably infect us. So that's a hypothetical question.
Cool.
Okay. All right. I think we take another question. I think the last question. Okay. Hafiz, the last question.
Okay, from where actually? You want me to take it from our social media or from the current, question from the...
Depends on you. Or we want Doctor to choose any question for
we have a lot of questions.
Audience.
Actually, people are actually excited to know more about Mars. Okay. Okay. I think I saw this question a lot. I mean, she really persistent asking the same question. Let's give her a chance. Okay, from this one. Okay, from Sainans Kumar. I think he already wrote a few times. Okay, let's give her a chance. Dr. Kundan, in your own astronomical view, will we bring back microbes from Mars back to Earth? Will we?
With the with the sample caching system of perseverance and so on, I'm assuming, right? So in my opinion, the samples will be sterile. And the most exciting thing we can hope for is that there's some evidence of past life, So probably not life there, which is living right now. Because if it was there are chemical signatures. So it's not, life basically announces itself, like with chemistry, non-equilibrium, things like that. It's structures. So we have tried to do that. We didn't find it. And we can possibly find extinct life, but we won't bring microorganisms back, in my opinion.
Okay, cool. Okay. Do you have any question? We don't have any time for that. I mean, I have one more question. I think that this one will be the biggest question ever.
Okay. We take for one last question. Okay. Hopefully, Doctor can take one more question.
Yeah, definitely.
Okay.
One more question. From who? From me? Okay, from I think the question will be representing all the question. Okay, despite of Mars. Okay, despite of Mars. Okay, we are talking about something that out of Earth, aliens, microbes, and everything. Do you feel or do you think is there any alien out there?
Wow, that's a good question. So
yeah, not just about Mars.
Yeah. So, well, if you ask me, the honest answer is I don't know. And sometimes you have to be satisfied with uncertainty. That's a good enough answer that you don't know. So there's a concept that only three numbers are important. One is 0, one is 1, and one is infinity. So right now we have 0 aliens so far. We have only one example, which is ourselves. So even if we find one example, so basically number is 1 right now. But if we find an example of alien life, it's probably out there in large numbers. So far we don't know. And sometimes, in science, science is always provisional. Every year, as you progress, your ideas of what's going on gets updated, and sometimes you have temporary answers. And right now, the answer is that we don't know, and we are so desperately trying to find out. We are sending robots to Mars and to fly on its surface and take samples and bring that. It's very expensive. It's very challenging, engineering-wise, and planning the mission and so on. So it's a big question, and we are doing our best. So
okay, so that one is the temporary answer, right? Until we find the real one.
Yeah. The most honest answer is we don't know, and we are trying our best to find out.
Oh, cool. Okay, guys. So be a astrobiologist, be a astronomers, be anybody you can help to find. Alien, if you want to.
Yes, you can do it in your life. Yeah.
Yeah. Okay, Azim. Anything else that I think we want to share with us, or where are we right now?
Actually, we already almost 1 hour 40 minutes going live for tonight. Yeah, I think we're going to end our session soon. Okay. First of all, I would like to thank you, Dr. Kundan Kadam, for the opportunity of you having us with us tonight, talking about a topic where we discuss: is there Martians or is there aliens in the space or in the universe? And I also thank to all our participants and our viewers that are watching with us from the early session until the end of this session.
Yeah, so we're really thankful for the insight and information from Dr. Kundam. I think it is a great sharing for us to get you share with us all about Martian, about space, and I think we as Malaysian really appreciate what you have done and your research. So for all the audience participants that watch this session, I think we learned a lot. So we are very thankful to the doctor.
Yeah, thanks for this opportunity. I'm very happy to be here. Yeah, a pleasure.
Yeah, we hope one day we will meet face to face. I hope the IAU meet will be happening next year. I'm not sure what gonna happen next.
Yeah, if we survive the viruses on the earth, we'll meet soon.
Okay, don't forget to take the COVID-19 vaccine first, Hafiz. Have you registered?
Not yet. I saw it. We need to update the apps today. Right?
The My Sejahtera app.
Yeah, we need to update the apps and also register for the vaccine. So, doctor, have you taken yours?
No. So in Canada, it's very slow. So
it's very slow.
In Canada, we ordered vaccines, but the country is prohibited export. So Canada has paid for vaccines, but they're still arriving. So not yet.
Okay.
All right. Okay.
Okay.
All right. I think we can end our session.
Yeah. Okay, but before we going totally end our session, okay, for doctor, we will need you to wait first in our lobby. We're going to have a short discussion at the end of our session. So please wait first at our lobby.
Thank you. Yes.
Okay. I think overall, we have speech here from our viewers to doctor too. I think I can share here. Yeah.
We have from Japan. Okay, I want to share from Japan. Okay, I want to share from Japan. We have our.
Okay, please.
Tomita-san, thank you.
Yes. Tomita is one of our universe awareness partner from Japan.
In Japan. Yeah. So thank you, Tomita-san, for sharing this event and watching it. All right. So thank you. We have a lot of appreciation from the participant.
Yeah,
Very happy to
my
have you.
pleasure. Yeah, I'm also very happy to be here.
Yes.
Alright.
Okay,
Okay, thank you so much, Doctor.
happy
See you after this. Just after
Yes.
this. Alright.
Yeah. So,
Thank you. Bye.
stay in the lobby.
Bye.
Okay, thank you. Okay, guys. Okay, are we
Okay,
going to speak
guys.
in Malay or English? Okay, we can speak in Malay, Azim. Okay, don't worry.
We can switch our language.
Okay, terima kasih semua.
Yes, thank you so much. Terima kasih semua kerana bersama dengan kita pada sesi pada malam ini. Ingat, kita belum habis lagi. Bulan penerokaan marikh ni, kita tak habis lagi kan, Cik Hafiz kan? Bulan penerokaan marikh kita ni.
Betul, belum habis lagi. Kita ada benda penting kita nak share tau sebenarnya. Okay, utamanya saya nak ucap terima kasih lah, banyak sangat soalan tadi.
Yes, betul.
Okay, Azim nak share something kan?
Yes, saya nak share sesuatu. Apakah next program kita pada minggu ini? Yang ni saya rasa adik-adik kita, golongan muda-muda ataupun tuan-tuan perempuan, abang-abang kakak yang mungkin pernah dengar nama-nama mereka ni memang dahsyat. Memang mesti kenal lah.
Memang lah. Kalau tak tengok rugi. Kan?
Betul. Itu dia. So pada Sabtu
sama dengan kita.
Apa ni Abang Hafiz? Cik Hafiz. Kejap abang, kejap Encik.
Okay.
Bos, silakan.
Tengok tu Hazim ni. Okay, kita ada ulasan filem. We have a film review, The Martian. Dari sains ke filem. Movie review dari sains ke filem tentang Martian. Kita nak tengok adakah apa yang dipaparkan dekat filem Martian tu reality sains ataupun tidak. Okay, kita akan ada dua orang yang akan bersama dengan kita pada hari Sabtu ini. Zami Muhyiddin. Okay, siapa yang kenal beliau banyak menulis pasal fizik, pasal sains,
astronomi, betul banyak. Dan beliau juga banyak menjawab tentang ahli-ahli konspirasi ni tentang flat earth ke semua. Memang rajin. Memang rajin melayan dan menyangkal
segala benda tu.
Dan seorang lagi kita ada Cik Haziq. Ataupun mungkin korang lebih kenal sebagai Abang Ajar. Okay, pembelajaran luar buku teks. Yes, kita akan bersama dengan dua tokoh kita kata public figure lah yang semua mesti kenal. Okay, kita akan bawa
Science
mereka
communicator.
Yes, Science Communicator. Pada minggu ini pada 27 Februari 2021 jam 9 malam. Itu dia. So nanti kan.
Kita ada 3 H1Z. Tapi nama kita semua ada Z.
Betul.
Okay. Baik, jangan lupa untuk ikuti kami. Kami ada di semua social media. Ada yang tanya tadi ada kat Instagram, tak ada. Kami ada dekat Instagram, kami ada dekat Twitter, kami ada dekat TikTok, kami ada dekat semua. Cari. Yes. Sekarang ni ada pun dah ada sebenarnya. Okay?
Tak ada, kesian. Kita tak buat PA, kita buat Haziq. Abang Ajar je ada.
PA dia mintanya.
Okay. Dan juga peringatan kepada pelajar-pelajar sekolah yang bersama dengan kita kan. Okay, kita ada program malam ni, ada sijil untuk anda. Okay, siapa yang belum daftar lagi boleh daftar di link yang tertera di ruang komen tu. Okay, sijil akan di-email kepada anda once it is ready. Bila dah sedia, kami akan emailkanlah kepada anda. Mungkin akan ambil masa sedikit dalam 3 ke 4 minggu sebelum ready untuk di-email. Sebab kita akan dapatkan pengesahan sijil daripada institusi kita. Kita ada MAISA dan juga Pusat STEM Negara dan juga KPM. Okay.
Yes. Okay, memang dah habis speaking dah. Kita kan akan speaking banyak lagi. Lepas ni kita nak cakap pasal syarat lagi lah apa semua kan. Okay.
Betul.
Jadi sebenarnya kita nak buat
eksklusif lah. Nanti belajar bahasa isyarat pula korang kan. Cikgu-cikgu tak ada sijil.
Cikgu-cikgu tak ada sijil. Okay. Pakai tanya saya, betul-betul lah saya. Okay, baik. Saya rasa tak ada masalah kot kalau kita nak bagi cikgu kita sijil. Okay,
boleh. Okay, macam tu sekejap. Saya edit sikit form ni. Okay,
edit sikit. Jadi Azim akan edit sikit form. Cikgu-cikgu boleh dapat sijil, tak ada masalah sebenarnya. Okay, kerana kita program pun di bawah Kementerian Pendidikan juga dan juga MOSTI, jadi sebenarnya boleh.
Yes, betul.
Okay. Jadi Hazim akan edit sikit form tu untuk isikan cikgu punya detail sikit. Okay, jadi boleh isikan nanti. Tunggu sekejap lagi. Okay, baik. So nanti kita akan ada banyak lagi program. Kita ada program Astro Inklusif pada hari Jumaat ni bersama dengan Sekolah Pendidikan Khas. Kita bercakap dalam bahasa isyarat kepada pelajar-pelajar khas kita tak mahu mereka terlepas peluang. Okay, for the inclusive people, visually and also hearing impaired, they will also learn about Mars. Okay, kita bagi mereka peluang. And also the one will be happen on Friday. Dan nanti hari Sabtu jangan lupa kita ada ulasan filem The Martian. Kemudian hari Ahad kita ada event lagi penutup. Okay, tapi along the way kita ada Sabtu. Sambutan bertuah. Banyaknya program pening saya. Okay, tapi tak apa, kami seronok sebenarnya.
Yes,
kita
betul.
ada lagi program sebenarnya Hazim kan, kita ada kem makassar cilik, kita ada
Betul. Code for space.
for space, so boleh semua kalau nak tahu lebih lanjut pergi pada website kami
Betul. Hafiz, saya dah updatekan form untuk guru-guru, for the teachers out there watching us for tonight's session. Boleh isikan link yang telah tertera. Okey, di ruang form tu ada tulis darjah tingkatan guru. Klik dekat guru tu. Sebenarnya anda adalah guru. Yes, betul.
Boleh jangan kat situ.
Jadi sebelum kita tamat, Cik Hafiz dan semua, kita akan tayangkan teaser. Teaser tentang The Martians. Saya tak pasti korang ni adik-adik ni pernah tengok tak cerita The Martian ni. Dia adalah cerita tahun 2015. Siapa tak pernah tengok dulu teaser ni. Dan kalau ada kesempatan, cari movie ni dekat internet. Kalau jumpa dan watch dulu. Tonton dulu movie tersebut.
Tonton sebelum dengar ulasan movie tu nanti baru nanti korang boleh faham.
Betul.
Ada masa ni sampai hari Sabtu ada masa lagi. Okey, jom. Kita dah ready? Alright.
Jadi kita tutup sesi kita pada petang ini, pada malam ini dengan tayangan movie official trailer. Official trailer The Martian. Alright. Jadi kita jumpa lagi di lain masa, di lain kesempatan. Thank you everyone for watching with us tonight. I'm Hazim from co-founder Apadilangit, and with me
Hafiz Murza, founder of Apadilangit. Thank you again. Thank you so much. See you again next time. Alright.
Bye-bye.
Bye-bye. Azim lambat. Ingat termenung.
Ada music tak?
Ada.
Alright.
I guarantee you that at some point, everything's going to go south on you.
Ready?
You're going to say, this is it. This is how I end.
Commander, Mark is dead. We have to go.
Now you can either accept that, or you can get to work. This will come as quite a shock to my crewmates, and to NASA, and to the entire world. But I'm still alive. Surprise. Here's the rub. It's going to be 4 years for another mission to reach me. And I'm in a hab designed to last 31 days. So I got to make water and grow food on a planet where nothing grows. But if I can't figure out a way to make contact with NASA, then none of this matters anyway.
We've got an incoming message.
Mein Gott. Mark Watney's still alive.
Woo! In your face, Neil Armstrong.
There must be some kind of way out of here.
Okay, so let's do the math. I have enough food to last for 50 days.
He's going to starve to death long before we can help.
So I'm going to have to science the shit out of this.
He's 50 million miles away from home. He's totally alone. What the hell is he thinking right now?
I am the greatest botanist on this planet.
I know how to save Mark Watney.
But we need the Hermes crew.
We either have a high chance of killing one or a low chance of killing 6. I'm not risking their lives. It's bigger than one person. No, it's not.
NASA rejected the mission.
So if we do this?
We're talking mutiny. If anything goes wrong, we die.
Do you realize how crazy this is? We have no other option.
No matter what happens, tell the world, tell my family that I never stop fighting to make it home.